It's time for fun with math, and today we are going to work this activity on working with trigonometric formulas, and this follows from your MyMathLab assignment. You'll notice here highlighted that the next couple problems here are similar to the problems from the assignment on trigonometric formulas, number 1 and number 2, number 1 and number 3. So what we want to do is we want to find the exact value for each expression, and each of these will involve the trigonometric formulas we covered in class. So let's look at the first one. We want to find the exact value for cosine of 7 pi divided by 4 minus 7 pi over 6. And so when I see this, what you should think is something like cosine of some angle, alpha, minus some angle, beta. And so this is one of our trigonometric formulas. Remember the way that we can memorize this formula. It's the sine has the same sign, but something's always different. And so the cosine has the opposite sign, but something's always the same. So the opposite sign of minus is plus, and the same part is that it goes cosine, cosine. So it's cosine alpha, cosine beta, plus sine alpha, sine beta. And so what we can do is we can use this formula here, where this is our alpha, and 7 pi over 6 is our beta. So this should be equal to cosine of 7 pi over 4 times cosine of 7 pi over 6, and then plus the sine of 7 pi over 4 times the sine of 7 pi over 6. And so now we have to evaluate each of these trigonometric expressions, and the easiest way to do that is probably to rewrite these in terms of sines and cosines of their reference angles. So we need to first, find where 7 pi over 4 lives, and then where 7 pi over 6 lives. So the idea as we'll do this, all students take calculus. So all students take calculus. I'll do this angle in green, so 7 pi over 4. That's pi over 4 7 times, so it's like 45 degrees 7 times. So it's 1, 2, 3, 4, 5, 6, 7. So there's 7 pi over 6. It, of course, has a reference angle, not 7 pi over 6, but 7 pi over 4. I'll just change that 6 to a 4 like that. So 7 pi over 4. Of course, it has a reference angle of pi over 4. So here's my reference angle, pi over 4. And so if you want, I can figure out that this is just the cosine, it's plus or minus the cosine, of pi over 4. And of course it's plus because it's in this fourth quadrant and the cosine is positive there. And then you have the plus in the middle, and over here you have sine of 7 pi over 4, so it's going to be plus or minus the sine of pi over 4. And it actually turns out to be minus, so I'll put a minus in front of it, and I'll put this in parentheses. And again, that's because it falls in the fourth quadrant, only cosine is positive, so it's negative sine of pi over 4. All right, let's find the next angle. Let's do this one in blue. So 7 pi over 6. So that's basically 30 degrees 7 times. So it's like 1, 2, 3, 4, 5, 6, 7. So here is the angle 7 pi over 6. It's in this third quadrant where only the tan is positive. And then you can figure out the reference angle here. It's pretty simple to do. Since it was 7 pi over 6, it's just 1 extra pi over 6. And so now I know that this cosine of 7 pi over 6 is really negative cosine of pi over 6. And this sine of 7 pi over 6 is really a negative sine of pi over 6. And now I can figure out these values from my reference table. So remember your reference table here, you have an angle theta, and you have 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And below that you can write degrees in terms of radians, so 0, pi over 6, pi over 4, pi over 3, pi over 2, and then you have the sine of theta, and then the cosine of theta. And so remember, you just got to remember 1, sine of 0 is 0, so it goes root 0, root 1, root 2, root 3, root 4, and these are all divided by 2. So divided by 2, divided by 2, divided by 2, divided by 2, and divided by 2. And then of course cosine of theta is exactly the same, you just write it the opposite way. So root 4, root 3, root 2, root 1, root 0, and then divide these all by 2. And so now when I want to figure this out, I want to find cosine of pi over 4. I simply look at my table and see that's root 2 over 2. So I replace that expression with root 2 over 2. Then I come here, I have cosine of pi over 6. And so this is going to be negative. And cosine of pi over 6 is right here. That's root 3 over 2. So I write root 3 over 2. And then plus, then I have negative sine of pi over 4. When I look at my table, there's pi over 4, there's a sine. It's also root 2 over 2, so negative root 2 over 2. And then finally, I have a negative sine of pi over 6. Well, here's pi over 6, so sine of pi over 6 is 1/2, so negative 1/2. And so that's equal to negative, so I have root 2 times negative root 3, so I'm going to get a negative root 6. And then I have a plus, a negative times, oh, let's divide it by this. So divided by 4, right? So 2 times 2. And then plus, a negative times a negative goes away. Then root 2 times 1 is root 2. And that's also divided by 4. And so this is just equal to negative root 6 plus root 2. And that's all divided by the number 4. And that is my answer. Now I can check my answer by simply looking at my calculator and saying, okay, calculator, turn it on and hit mode. Make sure you're in radians. So I'm in radians. And then all I need to do is check what is the cosine of 7 pi. So 7 pi divided by 4. And then take away 7 pi divided by 6. And so I get this as my answer. And then I can check whether it's the same thing as this negative square root of 6 plus square root of 2 divided by 4. So let's check that. So in parentheses, I'll put a negative second square root of 6, kick it out, plus second square root of 2, kick it out, and then in parentheses, divide by 4, and it checks. So I know I did it correctly. So let's look at the next problem here. So the next problem, I'm going to do cosine squared of 165 degrees minus sine squared of 165 degrees. And so now I'm in a similar sort of situation. This should be one of my trigonometric formulas. So I'm thinking, okay, well, when do I have some cosine squared an angle minus the sine squared of an angle? And that would be cosine of 2 times an angle is equal to cosine squared theta minus sine squared theta. So I can use this formula. So this would be equal to the cosine of 2 times my angle. Now, my angle here is 165 degrees, so 165, which would equal the cosine. And if you take 2 times 165, what do you get? So you have 2 hundreds and a 120, so what's that, 320, and then plus 10 more, so 330 degrees. And then how do you find the cosine of 330 degrees? Well, very similar to what we did before. I draw my little all students take calculus. I'll find where that angle lies. All students take calculus. So 330 degrees, well, here's 180, here's 270. Oh, so 330. Let's do this angle in red. This must be 330 degrees right about there. And of course, the reference angle gets you to 360, so that's just 30 degrees. And I guess I should write here 360 degrees. And so I see I'm in this fourth quadrant, which only the cosine is positive. What that means is that this is going to be the positive, the cosine of 30 degrees. And so that's going to be equal to, then, I come up here, I find 30 degrees. There's 30 degrees. And the cosine of 30 degrees is root 3 divided by 2. So root 3 divided by 2. And that's my answer. I can check my work, again, with my calculator. But this time I'm in degrees, so I have to go into degree mode. So go hit mode and go into degrees. And then I can just check this by writing left parenthesis cosine of 165, in parenthesis, raised to the 2, and then minus left parenthesis sine of 165, in parenthesis, raised to the 2. And it spits out an answer of 0.866, blah, blah, blah. And I have second root 3. Kick it out. I'm just going to check to see if these are the same. And they are exactly the same, so I know I did it correctly. And so the next problem, what we want to do, it's just like the problem from your MyMathLab assignment number 5. We want to use the information given to find the exact value of this given expression. So you have tan of alpha equal to 1/2. And then we know alpha is between pi and 3 pi over 2. And we know cosine of beta is equal to 3/5, and beta is between 3 pi over 2 and 2 pi. And so we want to find tan of alpha plus beta. So when I think of tan, I think I can rewrite that in terms of sine and cosine. So that's what I'm going to do, because I'm going to try to use my trigonometric formulas that I know to solve this problem. So I know that this is the same as sine of alpha plus beta divided by cosine of alpha plus beta. And so because I know this, then I can use now my trigonometric formulas, because I know the formulas for sine and cosine when you add two angles. So let's write these down here. So sine of alpha plus beta. Oh, I guess I can just write it right next to it. Okay, let's just write it right next to it here. So right here, remember the sine when you add two angles, the sine is always has the same sign, but something's different. So the different happens, it goes sine of alpha, cosine of beta. Sine of beta, cosine of alpha. Now the sine has the same sign, but something's always different. So the cosine has the opposite sign. So it has minus, but something is yet always the same. So cosine goes cosine, cosine. So it's cosine alpha, cosine beta. And then sine alpha, sine beta. And so now the idea is I want to figure out each of these. What is the sine of alpha? What is the sine of beta? What is the cosine of beta? What's the cosine of alpha? Cosine of alpha, cosine, so on and so forth. If I can figure out what those are, then I can just plug in. In fact, you actually already know what cosine of beta is. So where's cosine of beta? Here's cosine of beta right here. So I have cosine of beta on top and bottom, and that's just 3 divided by 5. So if you want, over here, I could leave a space for sine of alpha, and I could just write 3 divided by 5. And there's a space right here I got to fill in. And then plus, and then I have two spaces over here I have to fill in for the sine of beta and the cosine of alpha. And then divided by, leave a space here. I need to find the cosine of alpha, but I know the sine of the cosine of beta is, again, 3 over 5. So I have that space filled in. Then plus, and then leave a space here. Oh, not plus, but minus. So let's erase this little piece right here. There should be a minus. And so then minus, and then leave two spaces, because I got to fill those two spaces in. And so now how are you going to fill those spaces in? Well, you're going to use this information here, because we're going to figure out where alpha and beta live. So basically, remember we have this all students take calculus. And I know the quadrants that alpha and beta live. So let's do alpha in red. So alpha is between pi and 3 pi over 2. So here's pi, and down here's 3 pi over 2. So here's where alpha lives. So alpha lives right here in the third quadrant. And then where does beta live? Let's do beta in blue. And so beta lives between 3 pi over 2 and 2 pi. So it lives somewhere over here. And so beta is right there. And given this information and our old friend SOHCAHTOA, I can make some triangles and figure out the cosine of alpha and the sine of alpha, along with the cosine of beta and the sine of beta. And so let's draw our triangles here. So we have one triangle here. And let's do this triangle. Let's just make it red so it pops. So here's one triangle. We know this one, this triangle, we have the tan of alpha. So it's the TOA. So this must be the opposite, and 2 must be the adjacent. And so here, the opposite is 1. Of course, it's negative 1 because you're going down. And then the adjacent is negative 2. Right, the TOA, opposite over adjacent. And then for the beta triangle, let's draw that triangle. It's right here. It's the CA, so this is the adjacent. And this is the hypotenuse. And so we have a 3 right here. And then the hypotenuse is 5. And we got to find the other side. So we want to find this side of this triangle, which we'll label C. And we want to find this side of this triangle, which we'll label, let's say, B. And so we know Pythagorean theorem. So negative 1 squared plus negative 2 squared will equal our hypotenuse squared, so C squared. So that's 1 plus, and then if you square negative 2, you get positive 4 is equal to C squared. And so we get 5 equal to our C squared. And so we know that the square root of 5 is equal to our C. So that's equal to the square root of 5. Square root of 5. Okay, now to find B, we do the same thing. So we have a squared, which is 3. So 3 squared plus b squared is equal to c squared. So in this case, our c is the number 5, so 5 squared. And again, we do the same thing. So 9 plus b squared is equal to 25. If you subtract 9 from both sides, you get b squared equals 16. And so b must be equal to negative square root of 16, which is 4. And why is it negative? That's because it's going down. So b equals negative 4. And now we can find all our trigonometric expressions if we want to. So, like suppose you want to find the cosine of alpha and the sine of alpha. Well, you just use your right triangle. The cosine is the CA, so it's the adjacent over the hypotenuse. So it's negative 2 divided by square root of 5. And the sine is the opposite over the hypotenuse, so it's negative 1 divided by the square root of 5. And then over here, if you want to find the cosine of beta, which we already know, but we can use it as a good check. So cosine of beta would be equal to the CA, the 3 divided by 5. And the sine of beta would be the opposite over the hypotenuse, so negative 4 over 5. And we just plug in. So over here, let's find sine of beta. Well, here's a sine of beta, and there's a sine of beta. And so we know that's negative 4 over 5. So in this spot, we'll put a negative 4 over 5. In this spot, we'll put a negative 4 over 5. And then we'll find the cosine of alpha and plug in this negative 2 over square root of 5. So here's a cosine of alpha right here. So we'll plug in negative 2 over square root of 5. And there's another cosine of alpha right here. So we'll replace that with negative 2 divided by square root of 5. And then finally, we're left with our sines of alpha. We need to find sine of alpha, but fortunately, we've already written it down here. So here's sine of alpha, which is negative 1 over root 5. So we just plug it in, negative 1 over root 5. Just replace the sine of alpha, negative 1 over root 5. And the rest is just some arithmetic. So here you have negative 3 over, and we'll write this as 5 root 5 when you do the multiplication. And then plus, a negative times a negative is a positive, 8 over 5 root 5. And that's all divided by, so on the bottom, we have what? Well, you have negative 2 times 3 right here. And so you get negative 6 over 5 root 5. And then minus, a negative times a negative is a positive, so you have 5 on top. And then you have root 5 times 5, which we'll write as 5 root 5. And so that's going to be equal to, since they have a common denominator, we can add them together. So negative 3 plus 8 is 5. So you have 5 divided by 5 root 5. And then on the bottom, you have negative 6 minus 5, which is negative 11 divided by 5 root 5. And when you divide by a fraction, remember, you multiply by the reciprocal. So this is going to be equal to 5 divided by 5 root 5 times a negative 11. Oh, that goes on the bottom, right? So negative 5 root 5 on top divided by 11. And of course, when you do that, the 5 root 5s are going to cancel, and we're just going to get negative 5 divided by 11 as our answer. And of course I made a mistake, because it's so easy to make mistakes here. I do it all the time. So let's catch my mistake right here. Maybe you saw it already. Negative 1 times negative 4 is not 5. It's positive 4, which makes this negative 10, which makes this a 10, which makes this a 10, which makes the answer actually equal to negative 1 over 2. So remember, it's really important to just, show your work, because it's easy to make silly mistakes. All right, let's look at the next one. So on the next one here, what do we have? We want to verify. We want to verify the following identity. So remember how we verify trigonometric identities, and this will look like number 7 on your MyMathLab assignment. So the idea is you choose a side, and you work from that side and go to the other side. So I'm always going to choose the left-hand side, because that should have the right amount of information. So we're going to start with this, cosine of 3 pi divided by 2 plus theta. And I want to somehow turn this with a string of equalities into a sine of theta. Well, this is one of my types. It's following this formula, cosine of alpha plus beta is equal to, now remember, sine is the same sign, so the sine has the opposite, something different, but something's the same, so it goes cosine of alpha, cosine of beta, sine of alpha, sine of beta. And so the idea is that this is like your alpha and this is like your beta, and so we just use our formula. So by this formula, this would be the same thing as cosine of 3 pi over 2 times the cosine of theta, and then minus the sine of 3 pi over 2 times the sine of theta. And so now we're just going to need to figure out what the cosine of 3 pi over 2 is and what the sine of 3 pi over 2 is. There's several ways to do this. If you just wanted to use the unit circle, you could do that, because it doesn't say we have to use reference angles. So if you look on your unit circle, you'll see the cosine of 3 pi over 2 is a 0. So that's a 0 times cosine of theta. And then minus, you'll see the sine of 3 pi over 2 is a negative 1 times sine of theta. And this is going to be equal to, of course, this term's going to go away, because 0 times anything is 0. And then minus a negative is a positive sine of theta. And we're all done. We've verified the trig identity by going from the left-hand side to the right-hand side, using a string of inequalities, and then the trig formulas we're supposed to be familiar with. All right, let's move on to number 8. So now we're going to introduce some inverse trigonometric functions or expressions, if you like, into our problems. This is just like 10, 11, and 12 on your MyMathLab. So how do we do this? So again, I look at this sine, a sine inverse of 5, 6 plus cosine inverse of negative 2 over 3, and I think to myself, remember, these aren't just anythings, right? This and this are special things. They're angles. So I'm going to call this angle my alpha, and this angle here my beta. And so I can rewrite this, if you like. This is going to be equal to the sine of alpha plus beta, which then you'll say, oh, that's one of my formulas. I can use one of my trigonometric formulas to simplify this. All right, so below here I'm going to write, that's where alpha was equal to sine inverse of 5, 6. And beta was equal to cosine inverse of negative 2 over 3. And so what is this equal to? Well, we can use our trig formulas. So remember, sine always has the same sign, so you're going to have a plus in the middle, but yet something's different. So it goes sine alpha, cosine beta. So the difference is the cosines, the sine cosine. And then you have sine of beta, cosine of alpha. And the idea is we just need to figure out, what is the sine of alpha? What is the cosine of beta? What is the sine of beta and the cosine of alpha? And some of this we already have, because over here we have a relationship. If you sine both sides here, the sine inverse will go away. So we'll sine the alpha, and then when you sine the sine inverse, it goes away. They undo each other, and you just get 5, 6. And then for over here, we can cosine both sides, and we'll get cosine beta is equal to, if you cosine the cosine inverse, it's going to go away, they're going to undo each other, and you get negative 2/3. And so what we have here is I know the sine of alpha. So the sine of alpha is 5, 6. So what I can do is I can replace my sine of alpha with that 5, 6. So that's equal to, I'll put a 5, 6 there. And I'll make a space because I don't know what cosine of beta is, and I'll draw a plus. And I don't know what, I lied. I do know the cosine of beta. Cosine of beta is negative 2/3. So I can put negative 2/3 there. And then I'll put a space here because I don't know what the sine of beta is, and I'll put a space here because I don't know what the cosine of alpha is. So I need to go find those. And the way that we're going to find them is we're going to bring out again our old friend. All students take calculus. So we're going to recreate just the part of the unit circle we kind of need, and we can find the values for cosine of beta and cosine of alpha. So how are we going to do this? Well, alpha is equal to sine inverse of 5, 6. So sine of alpha is equal to 5, 6. So really we're solving a trigonometric equation, but this one, remember, only has one answer. So for sine of alpha equal to 5, 6, which quadrant can you be in? Well, you can't be down here because the sine's negative down here. So you're one of these two quadrants. And there's just one answer, so you pick the nicest one, which would be the first quadrant. So this is where our alpha lives. So here's my angle alpha. And then let's find where this angle beta lives. So cosine of beta is equal to negative now. So the cosine's negative, so we know it can't be here or here because the cosine's positive there and there. So it must be in one of these two quadrants. And we got to choose one. So the nicest one, of course, is the second quadrant. In fact, none of the inverse trig stuff can live down here. So this must be our beta. So there's beta. And so from these two pictures, we can get two right triangles. So here's one right triangle. And then over here is the other right triangle. And we can label the sides using SOHCAHTOA. So we know SOHCAHTOA. So let's write down SOHCAHTOA. And so because this is the sine of the alpha, if this is the SO, must be the opposite over the hypotenuse. So you come here, here's my alpha. The opposite side is always the output, the y value. So it's a 5, and the hypotenuse is 6. We need to find this remaining side, which we'll call A, and we can do that just like we did before. We use Pythagorean theorem. And so we know that A squared plus 5 squared is equal to 6 squared. And so A squared is going to be equal to, this is going to be 36 and 25, so you subtract those two, it's 11. And so A is equal to the square root. So A is equal to the square root of 11, and it's positive because you're going to the right. So you have square root of 11 here. And then for the red triangle, we're going to use this as the beta. So this is the CA, so this is the adjacent, and this is the hypotenuse. And so the adjacent side is the input, it's the x stuff, so negative 2. The hypotenuse is always positive, so it's a positive 3. And then to find this side, this b, again, we're going to use that Pythagorean theorem. And so we know that, negative 2 quantity squared plus b squared is equal to 3 squared. And so we get 4 plus b squared is equal to 9. And when you subtract, we get b squared equal to 5. which tells us that our b is just going to equal, our b is just going to equal plus or minus the square root of 5. And of course, we'll take the positive piece because we see b's going up. So this equals the square root of 5. And so from this information, we can compute what we're missing. So, we want the cosine of beta and the sine of beta. Or I guess we already have the cosine of beta. We want the sine of beta, though. So over here, if you want, we can write sine of beta. And it's equal to, we're using the red right triangle. It's so it's the opposite over the hypotenuse. So it's root 5 over 3. So wherever I see a sine of beta, I'll replace it with its value, root 5 over 3. And then I need a cosine of alpha. And so I'll use the green triangle, the alpha triangle, basically. And if you want, I can write down cosine of alpha. It's the so it's the adjacent over the hypotenuse. So square root 11 over 6. So I write square root 11 divided by 6. And so then that's equal to, I can multiply this together. 5 times negative 2 is negative 10 divided by 18. And then plus root 5 times root 11 is just square root of 5 times 11, so square root of 55, divided by also 18, 3 times 6. And so for my final answer, I can write down this is equal to negative 10. They have a common denominator, so I can bring them together, plus the square root of 55 over 18. And so now to check my work, because it's easy to make a mistake on these, I'll take out my calculator, I'll turn it on. I'm going to clear this out, and I just plug this in, the sine of second sine, so sine inverse of 5 divided by 6, in parentheses for the sine inverse, plus second cosine to pull up the cosine inverse, negative 2 divided by 3, in parentheses for the cosine inverse, in parentheses for the sine, hit enter, it spits out this answer, and then I want to make sure that it's the same as this one down here. So left parenthesis negative 10 plus second square root of 55, kick it out, in parentheses divide by 18. And it gives me that answer. They're exactly the same, so I know I did it right. Let's look at another one of these. So in the next problem, we have sine of 2 times cosine inverse of negative 1 over root 2. So again, when you look at this, it's like, what the heck do you do? What you have to remember is that this thing right here, cosine inverse of negative 1 over root 2, isn't just anything. It's actually an angle. So we'll call it theta. We'll say this is equal to sine of 2 theta. And as soon as I do that, my brain says, oh, that's one of my trigonometric formulas, so I can use that. So here, down here, I'll remind myself, remember theta is equal to cosine inverse of negative 1 over root 2. And I can use one of my trig formulas that says sine of 2 theta is equal to what? Well, that's equal to 2 sine theta cosine theta. And so my goal is to figure out what sine of theta is and cosine of theta, and then I can solve the problem. So down here, I can do that because I can take the cosine of both sides. So the cosine of theta will equal the cosine of cosine inverse, which they undo each other, and that's negative 1 over root 2. So part of this problem, half of it's now done because I know what cosine of theta is, so it's going to be equal to 2. I'll leave a big blank right here, and then I'll put in for cosine theta, negative 1 over root 2. So now my job is just to find what sine of theta is. So to do that, again, I draw that piece of the unit circle that I need, basically. So all students take calculus. I see that the cosine is negative. So where does the angle live? Well, it can't live here, and it can't live there. Angles in these two quadrants, when you take the cosine, they're positive. So it must live in one of these two quadrants. And now because I'm working with that cosine inverse, I'm only going to get one answer. So I pick the one that makes the most sense. So I knock that one out because that never works. So my theta lives right there. So there's my theta. And to find the sine of the angle, all I need to do is make the little right triangle. So here's my right triangle. And then use my old friend, SOHCAHTOA. So this is the cosine of the angle. So this is the CA. So it must be the adjacent over the hypotenuse. And so the adjacent, this is where the negative goes because you're going to the left, -1. The hypotenuse is √2. I'm looking for this side, which I'll call B, and just use the Pythagorean theorem. So -1 squared plus B squared is equal to square root of 2 squared. And so I get 1 plus B squared is equal to 4. And so B squared equal to 3. You subtract 1 from both sides. And B is equal to plus or minus √3. And we'll take the plus part because it's going up. So B must be equal to square root of 3. And so if you want the sine of theta, what is it? So sine of theta, it's the opposite side, which is √3, over the hypotenuse, which is √2. And so this is just going to be √3 divided by √2. And then we do the multiplication. So you have 2 times √3 times a -1, which is -2 √3, divided by, in the bottom you have √2 times √2, which is 2. The 2's are going to cancel, and we just get negative square root of 3 for our answer. And now we can also check this with our calculator. And so with our calculator, what do we get? Let's check it, because again, it's easy to make mistakes. And so on my calculator, on this one, you get what? So you have sine of 2, and then second cosine of -1 divided by second square root of 2. Kick it out, in parentheses for cosine inverse, in parentheses, and I get this answer. Whoa! And I see, oh, those two answers are not the same, which means I probably made a mistake. And you may have caught it before I did. Right here, there's the mistake. Square root of 2 squared is not 4. It's the number 2. Oh my goodness. All right, so that should be the number 2. And of course, then if you take away 1, you get 1 here. And then the square root of 1, of course, is just the number 1. And so really, my B should be 1. And so sine of theta is actually 1 over √2. So up here, you put a 1. And over here, then, you get 2 times 1 times -1, which would just be a -2 divided by 2. And of course, these do cancel. And instead of getting negative √3, you get this equal to -1. Aha. So definitely want to try to check your work if you can, because it's easy to make mistakes. But again, if you made this mistake, I probably wouldn't take off anything. So I'm like, I see exactly what you did. It's a silly mistake. It's easy to make mistakes when you're doing arithmetic. As long as you're not violating an algebraic property, you're good to go. All right, let's see if I can do this one without screwing it up. All right, so again, it's a very similar idea. I have the cosine of 2 times sine inverse. And so I look at this and say, hey, that's not just anything. That's an angle. So that's going to be equal to cosine of 2 times theta. And that's one of my trigonometric formulas. There are lots of ways to express it. So let's just go through them over here to remind you what they are. So cosine of 2 theta, we can write this as a difference as cosine squared theta. Instead of plus, you can write it as minus sine squared theta. That's one way to do it. Or you could rewrite this as 2 cosine squared theta minus 1. Or you could actually rewrite this as 1 minus 2 sine squared theta. These are all good answers or formulas for cosine of 2 theta. It doesn't matter which one you choose. You can choose either one. For fun, I'm just going to choose the top one, but you could choose the other two also. So this will be equal to cosine squared theta minus sine squared theta, where, remember, theta is equal to sine inverse of x. And so our job is to try to figure out, what is the cosine of theta and then square it? What is the sine of theta and square it? And this is the key. So we can sine both sides, and that'll tell us what sine theta is. So sine theta is equal to, if you sine the sine inverse, so it's going to go away, and it's just equal to x. And so we get part of this for free. So right now you can plug in an x and get x squared, but you still have to figure out what cosine of theta actually is. And so here, to figure out cosine of theta, we can make our little triangle. Now we don't have to do all students take calculus because we have x and not numbers. We always just assume this one's in the first quadrant. And so here's our theta, and we can use our old friend SOHCAHTOA. And so the sine of theta is the opposite over the adjacent, so this must be the opposite. And this must be not the adjacent, I'm sorry, the hypotenuse. So it's the So opposite over hypotenuse, and so the opposite side, opposite the angle is over here. So that's x, the hypotenuse is 1, and I have to find this side a. And so to find a, again, I can use the Pythagorean theorem. So a squared plus x squared is equal to 1 squared. And so my a is equal to 1 minus x squared, subtract x squared from both sides, and then take the square root, that's a squared, sorry. A squared is equal to that, and then take the square root, and it is plus or minus, but we'll always pick the positive piece when we're working with x stuff here. And so this a is actually equal to the square root of 1 minus x squared. And so up here, when we plug in for cosine squared theta, we'll take this a, oh, I guess I should write down here. So cosine of theta is equal to the the adjacent, which is square root of 1 minus x squared, divided by 1. And so that's just equal to the square root of 1 minus x squared. And so when we plug in here for cosine squared theta, we'll square this, the square root will go away, and we get 1 minus x squared. And of course, 1 minus x squared is 1 minus 2x squared. And there's our answer. Remember, you can check your work on this one too by plugging a number in for x. You have to be a little bit careful about what you're going to plug in though. So you want to plug in a number, or sine inverse can only take in numbers between -1 and 1. So here you might want to plug in, cosine of 2 and then sine inverse. If you try to plug in a number bigger than 1, it won't work. So let's plug in, 0.5 because that'll work. So let's let x be 0.5 in parentheses, and we get out this number. And so then you do 1 minus 2 times. So plug in 0.5 here for x. And if we did it right, these should be exactly the same. And they're exactly the same, so I think we did it right. So we're good to go. Let's check out the last problem here. And so now, finally, we're going to solve some trigonometric equations. We're just going to do this one. But it's just like 14 from your MyMathLab assignment. And so to do this, what you have to do is use another one of your trig formulas. So when you look at this, you should think, this is one of my trig formulas. The idea is that this is like an angle alpha. X is like your angle beta. And over here you have your, beta and alpha. And so if you think about this, this has this sort of form, sine of alpha, cosine of beta, minus sine of beta, cosine of alpha. So what can that be? Well, that must be the different is the sine cosine, so that must be the sine. And this sign is the same for the sine, so it must be alpha minus beta. And so we can rewrite this as on the left-hand side as sine of your alpha is 4x, your beta is an x, so minus x, and that's equal to root 2 over 2. And so 4x minus x is 3x, and so now we have the sine of 3x is equal to root 2 over 2. There's equals right there. And now we can solve this problem because it has the right form. So remember, when you're solving trigonometric equations, you basically have to rewrite this as the sine of something equal to something, or the cosine of something equal to something, or the tan of something equal to something. And then we can solve it. Right? And the way that we solve it, we can solve this one exactly. We don't need to use a sine inverse on it. But we can solve it exactly. All students take calculus. And we know that the sine of the angle is positive, so we know it can't live down here because the signs are negative in those quadrants, so it must live here. You're going to get all the answers, or you're going to eventually find all the answers between 0 and 2 pi, but you have to find all of them first. And then we could find them between 0 and 2 pi by counting them off. So you get those there, those two answers. We know the reference angle because we have the reference table we made in the very first problem. So you look for root 2 over 2, and you say, oh, the angle's pi over 4. So here's my reference angle, pi over 4, and pi over 4. And then we can read off the answers. So our first answer will be 3x equals, so notice the angle is 3x, not just x. And the first answer is pretty easy to write down. It's just this angle right here, which is pi over 4. But remember, you can add any multiple of 2 pi, where n is a nice number, right? It's an element of the integers. So it's 1, 2, 3, 4, or so on, or it could be 0 or negative 1, negative 2, negative 3, negative 4, or so on. And then the second answer goes from here to here. And so over here, let's write 3x equals. And so to find the second answer, you can count it off, or you can pretend like you went halfway around, which is pi, and then you went back pi over 4. And then you can find a common denominator. So this is really 4 pi over 4 minus pi over 4. And 4 of these take away 1 of these is 3 of these. So you get 3 pi over 4. So my second answer is 3 pi over 4. But again, you can add any integer multiple of 2 pi. So 2 pi n, where n is an integer. So n is an element of those integers. So we're still not done. We have to solve each of these for x. So to solve each of these for x, we're going to divide out by 3. Or if you like, just multiply everything by a third. And so if you multiply everything by a third, you'll get x here, because 1/3 times 3 is 1. If you multiply this by a third, you get pi over 12. Plus, if you multiply 2 pi n by a third, you just get 2 pi n divided by 3. Over here, we do exactly the same thing because we're solving this for x. So we multiply by a third, and you get x equals. If you multiply this, because you multiply by a third, if you multiply this by a third, the 3's are going to cancel, and you just get pi over 4. Plus, then you multiply this by a third, so you get 2 pi n over 3. And now we want to count off the answers, but to make this simple on ourselves, right? When I say count off, we want to do like n is equal to 0. And then we want to do n is equal to 1 and see how many we get. And if we get bigger than 2 pi, we have to stop. Or smaller than 0, we have to stop. So n equals 0 is actually pretty easy. If n is 0, this term's going to go away, and we should get pi over 12. When n is equal to 1, this is a little bit harder because they don't have a common denominator. So sometimes it's easier if you just put these in, give them a same sort of common denominator. So multiply top and bottom by 4, and so it's a 8 pi n over 12. And so now if you see if n is 1, you just get 8 pi's plus a pi, which is 9 pi over 12, comma. If n is 2, what happens? This is 16, so 2 times 8 is 16, plus 1 is 17 pi's over 12. And that's still an answer because you're not bigger than 2 pi. But if n is 3, let's see what happens when n is equal to 3. When n is equal to 3, you get 24 here, 24 pi's plus 1 pi. And so you get 25 pi over 12. But that's too big, because 25 divided by 12 is bigger than 2, so that's too big. So these are the answers you get right here. So that's the first 3. And then the second 3 are going to come from this one. So x is going to equal, if n is 0, this term just goes away, so you just get pi over 4. But now we run in the same problem that we did last time. When n is equal to 1, we don't have a common denominator. So let's get a common denominator. We'll multiply this one top and bottom by 3. So 3 pi over 12. And then plus, multiply top and bottom by 4. So 8 pi n over 12. And now it's easy to count. So this was when n equals 0. And then if n is equal to 1, this will be 8 pi's plus 3 pi's, which is 11 pi's. So 11 pi over 12's. And then when n is equal to 2, this will be 16 pi's plus 3 pi's, which is 19 pi's over 12. And of course, if n is equal to 3, it'll be too big. And of course, if n is negative, all these will be too small. So these are all my answers here. You notice you get 6 of them. If you want to, on this problem, you can actually reduce this one, but you don't have to. I think it's enough just to get all the answers. But if you want to, you could rewrite this. You know, pi over 12 stays. It doesn't reduce. But 9 pi over 12, the 3's will cancel. And you get 3 pi over 4. And finally, this one stays the same, 17 pi over 12. So if you want to reduce, you can, but I don't actually make you guys do this on this one. On MyMathLab, you probably should reduce to get all the answers. And that's it, right? So that's the end of this activity. I know these problems are very challenging, so give them, your best shot. Try to use this video, these solutions to help you. Good luck.